What I'd like to show you today, students, is how to solve a system of equations. That is, to find the point where two sets of lines would intersect. And I'm actually going to do these two equations that you see listed here by three separate methods. The first thing I'd like to do is to solve it by graphing. Then I'll do substitution, and finally the addition-subtraction method. Now, I've given you these equations in two different forms. First of all, this one is really graphing friendly. It is already in the y-intercept form. This one is not. We need to prepare this one a little bit more and get it ready for graphing. One thing you could do, frankly, is to go ahead and solve this equation for y, thus by putting it in the y-intercept form. But I'm going to take a different route, the one I prefer to take when it's in this form. I'm going to find both the x and the y intercepts. So first thing I want to do here is actually substitute a 0 in for x. When I do that, essentially what happens is the 2x goes away. Think about that for a minute. We have 2 times 0 minus 3y equals negative 7. But you see what happens. 2 times 0 is 0, and 0 minus 3y is just minus 3y. I'll now divide both sides by my negative 3, and I actually find the y-intercept. Now the y-intercept is 2 1/3, or if you prefer, 2.3 repeating. Now let's do exactly the same thing for the x-intercept, and you see this time that when I put a 0 in for y, the y term goes away. So if I have 2x minus 3 times 0 equals negative 7, again, when I put a 0 in for y, this goes away. And I merely have 2x equals negative 7. And at this point, to solve this equation, I merely divide by positive 2, and I get negative 7 halves, but I think it's easier to think of that as negative 3.5. So let's go ahead and graph these 2 points that we found. Well, actually, let's go ahead and graph both lines, frankly. Let's do the easy one first. Y equals 3/4 x plus 2. Here's my origin, down here where I have this red dot, and my intercept is at plus 2. So I just come up to the y-axis. I know that this crosses the y-axis at positive 2. And remember what my original equation was. The intercept, I know if I plug in a 0 for x, I'll get y equals 2. I know that's where it crosses the y-axis at positive 2. Now I also recall that the number in front of x, the coefficient of x, if you will, is the slope, which is the change in y over the change in x. So specifically, to get from this point to the next point, I go up 1, 2, 3, and over 1, 2, 3, 4, and that with the 2 points gives me the equation of the first line. Now let's take a look at those points that I got for my x and y intercept. Remember, I know that it crosses the y-axis, or excuse me, x-axis when y equals 0 at x equals negative 3.5. Now, that's a little more difficult because it is a decimal, but that would approximately be at 1, 2, 3, and let's say a half right there. And then I know it crosses the y-axis at 2.3. Again, if x equals 0, y equals 2.3, and 2.3 is even a little tougher to get, but that'd be about 1, 2, 2.3 I would estimate is roughly right there. Frankly, those two lines are almost parallel. And let's go ahead and graph this line. And it's a little difficult to see, frankly, with this thick pen, which I didn't anticipate, frankly. But this is the point of intersection. At the point, at the point 4, 5. In other words, x is 1, 2, 3, 4, and y is 1, 2, 3, 4, 5. Now, to be honest, a graph usually only gives you an approximate value anyway. You can't be assured that this actually goes through whole numbers, and it would be very difficult to tell the difference between 4.1 and 4.0, or for that matter, 4.99 and 5. So this graphing method, frankly, really only gives you an approximate method, or excuse me, approximate answer. Let's go ahead and look at the methods that will give you the exact method, the algebraic solutions, if you will. And let's first do this by the substitution method. Now, to be honest, these equations, this one in particular, is made for doing the substitution method. And frankly, on WebAssign, unfortunately, all of the problems you're given work with the substitution method best. But I still think it's appropriate if you learn to practice with the other method, the addition-subtraction, which I will show you momentarily, because you will be required to do both on the test. But let's go ahead and look at this as a substitution problem again, because that's the way it's set up. This one is already in the y-intercept form. So it's already solved for y. What I need to do then is to take this value, which I know equals y, and substitute it into the other equation for y. And let's take a look and see what that gives us. I'll have basically 2x minus 3 times y equals negative 7. Well, now what we have to do is solve this algebraically. Let's go ahead and do that. First thing I think I would do is multiply through my equation by negative 3. Negative 3 times a positive 3/4 would give me a negative 9/4. And negative 3 times a positive 2 would give me a negative 6. Well, now I've still got this nasty fraction I'm going to have to deal with. And to get rid of the fraction, we will multiply both sides by the one and only denominator I have here, which would be the 4. So I'll multiply both the left side and the right side of my equation by 4. Let's go ahead and do that. The 4 times my 2x gives me an 8x. The 4 times my negative 9/4, in this case the 4's cancel exactly the way I wished, which gives me just negative 9. And finally 4 times negative 6 is negative 24. On the right side, it's simply negative 7 times 4, which is negative 28. Now it's easy to solve. There's no parentheses, there's no fractions. Let's go ahead and do it. Quite simply, I'll go ahead and combine my like terms. 8x's, if you win 8x's at the crap table, and then you turn around and lose 9x's, that puts you 1x in the hole. And then I go ahead and bring down my 24 and 28. Now I'm going to get rid of the 24 by adding 24 to both sides of the equation. Here on the left, those values cancel and I'm left with negative x. On the right, that'll leave me with negative 4. Now at this point, I'm almost done. I just need to make sure I solve for positive x. So I either multiply both sides by negative 1 or divide by negative 1, and that gives me my final solution of x equals positive 4. But keep in mind, this is only the x coordinate. I now need to find the y coordinate. And if we look back up at our original equations, in this particular case, I think it's much simpler to plug the 4 in to the equation on the left in the y-intercept form. You could plug it into the other one, but again, it's much easier to do the one on the left, so we'll go that way. Plugging in a 4 into this equation gives me the following. So I have my y equals 3/4 times x, which is 4, plus 2. Once again, my 4's merely cancel, which gives me 3 plus 2 equals 5. So once again, it's the same solution I had a minute ago. Y equals 5, x equals 4. If I list it as a point, I get exactly the same point that I found graphically. Now finally, let's look at the addition-subtraction method. Once again, I'm going to work with the same equations. The one on the right is ready to go as far as the addition-subtraction method is concerned, but the one on the left needs some work. Let's first multiply through both sides of the equation by 4. Multiplying the left and right by 4 gives us the desired effect. It gets rid of that fraction. Doing this, 4 times y, of course, is just 4y. 4 times 3/4 will cancel my 4's, and I'll just be left with 3x. And my 4 times 2 is 8. Now, I merely divide both sides of my, I merely subtract 3x from both sides of the equation. Over on the right side, those terms cancel, and I'm left with, if I put it in the proper order, negative 3x plus 4y equals 8. Now let's go ahead and bring down our other equation, which you recall was 2x minus 3y. I'll put that directly underneath my other equation. Now this is called the addition-subtraction method because what you want to happen is to have one variable or the other cancel when you add or subtract. Now I will only ever use the addition method. I find students too often make an arithmetic or a sign error when they use the subtraction method. I will always want to add. Luckily for me in this particular situation, one of them is negative and one of them is positive. Whether I pick the x or I pick the y's, that's the case. So it works out great for me. In this case, I think I'll go ahead and get rid of the x values because, frankly, for no other reason than they're smaller. In this case, I look for a value that both 3 and 2 will divide into. That value is 6. So I'll need to multiply the top one by 2, which will give me negative 6, and the bottom value times 3, which will give me positive 6. And then those will cancel out when I add the equations together. And let's take a look and I'll show you what I mean. If I multiply through the top equation by 2, that will give me a negative 6x. Multiplying the bottom by 3 will give me a positive 6x. And again, here's what that's going to look like. Now, I can't just multiply the first term. I, of course, have to multiply both sides of the equation by 2. So 2 times my negative 3x is negative 6x. 2 times my 4x gives me my 8x. And 2 times my 8 gives me my 16. On the bottom equation, I'll multiply both sides by 3. 3 times 2x gives me a positive 6x. 3 times negative 3y gives me a negative 9y. And finally, 3 times negative 7 gives me negative 21. And observe what happens if I add the two equations together. Remember, if I have two things that are equal, and I add equal things to both sides of the equation, I end up with two more things that are equal. In this case, the negative 6x and positive 6 will cancel. My 8y and negative 9y will yield a negative y. Again, if I have 8 y's and I take 9 away, I am 1 y in the hole. And by the same token, if I have $16 and I lose $21, I'm now $5 in the hole. I have a similar situation that I had on the last example. I want what positive y equals, so once again I will divide both sides by negative 1 or multiply both by negative 1 and get my solution y equals 5. Now once again, I have only one value. I have the y value. I need the x value. Remember our two original equations? I have to pick one of those to plug y back into. Plugging y into the one on the left this time is not a pretty picture. You could do that, of course, but it would be much more simple if I plug into the equation on the right. So let's go ahead and do that. And I have 2 times x minus 3 times y, and I will of course put my 5 in for the y value, equals negative 7. Now, negative 3 times negative 5 is negative 15. I can eliminate that negative 15 by adding 15 to both sides of my equation, which will give me on the left just 2x. On the right, if I'm 7 in the hole on the first bet, win 15 on the second bet, I have $8 altogether. Now, all I have to do is get rid of the 2. I'll do that by dividing both sides of my equation by 2, and I end up with my final solution of x equals 4. So my solution again is 4, 5. Now, I didn't do this before, but once again, it's a good idea to plug that point into the other equation to make sure it works. And let's talk about that. I would have y, which I believe is 5, is supposed to equal 3/4 times x, which I believe is 4, plus 2. And again, I've just taken my other equation, plugged the 5 in for the y, and the 4 in for the x. See what happens on the right side of the equation? The 4's cancel, and I'm left with 3 plus 2, which of course does equal 5, and verifies that I have the correct solution.